Well, so what we've got is I want to run through some of the basic materials that are provided by both SolarSense and Wires and Bytes. SolarSense was originally conceived to try and help bring fiber to the market to a much wider audience. It was always seen as being a bit of a specialist thing, but it's becoming more mainstream, and people need help to bridge the knowledge gap to go up that learning curve as quickly as possible. And so what we've tried to do is to make the equipment that we select as easy to use as possible, go for simple acquisition and fast and effective processing. And we do that through combining a number of different suppliers of equipment. So we've partnered with Wires and Bytes, and they supply the cable and the fiber that goes into the well. But more specifically, they're actually very fleet of foot when it comes to designing cables that are specific to your requirements, whether that is a particular temperature and pressure, or hostile chemical environment, or specific weight load bearing capabilities. And so I'll leave that to Peter in Wires and Bytes to run through that material with you. We also have partnered with principally AP Sensing to provide the interrogation units. That's the surface unit that pulses down the fiber and acquires the data. And then if you need something that's even smaller and more portable, then we do also partner with Viavi to provide that. But mainly it's we work with the incumbent service company who is providing the SlickLine or electric line service, and work with them to get them up to speed on fiber and get them converted over so that they can offer the service themselves, and with the operator staff, their end customer, to make sure that they are comfortable with what they can ask for, what the fiber can do for them, and make it as holistic a service as possible. We do apply this technology over quite a number of different types of well issue, from what's flowing through to cross flows and well integrity applications. So there's a large number of applications that it can be employed against, but also over the whole life of the well or the field. So everything from a new well right the way through to decommissioning and well abandonment. And so it actually has quite a broad applicability over many different applications and over the full life cycle. And so it becomes a very useful tool to the operator. I don't want to say too much about the wire because Peter will go into that, but suffice to say that we have supplied wire and the connection boxes that go along with that to make sure that we've got an appropriate connection in the system. And indeed, we can offer both 100% fiber or fiber with copper. And again, Peter will talk about that a little bit more. And I think Peter's already got some of these slides, so I'll skip over those. When it comes to the interrogation units, there are a number of different types of unit that you can specify. The one that we've tended to go for temperature purposes has been a single mode unit with a 12-kilometer range, which is applicable to most of the well integrity type applications that we're being asked to address, but it doesn't mean to say we're restricted to that. AP Sensing can manufacture a range of other units that are able to cope with different measurement requirements. And so again, if we understand the measurement requirement that has been asked, then we can recommend the specific box that's appropriate for that. And then likewise with the acoustic unit, the DAS unit, we've tended to go with, again, a 12-kilometer unit with a variety of spatial sampling and gauge length metrics, pulsing up to 20 kilohertz, and with built-in storage. And that tends to be the unit that's most versatile for the types of application that we've been asked to support and service to date. So when it comes down to what is physically on site and what does a service company need to get up and running with this service, the interrogation units are all packaged in their little transit pelly cases and are pretty robust and rugged. That's the DAS DTS units in their transit cases, and the whole lot is controlled from just a laptop. So it's quite a self-contained little package, and we have a surface cable that we provide that connects the interrogation units to the connection box on the drum, and then the actual drum of wire itself. And really that's all you need. The winch units are the same, the crews that you employ are the same. You will need one member of your crew who specializes in making sure that they can operate the fiber equipment. But we have trained up operators in the past. If they're used to running cased hole production logs, then they tend to be pretty good at picking up the fiber equipment and running with that. So it tends to be, quite similar to what they've had to do for other production log type operations. So the software, and one of the things that has always been a bit of a blocker for many people in the industry has been the size of the data sets that we gather and the complexity of what we do with that data. And we were very conscious about that as being a big barrier to broader acceptance of fiber in the industry. So what we wanted to do was to make the software as simple as and intuitive as possible, and without losing the sight that we had to reduce the size, particularly of the DAS data, because that generally ends up being terabytes worth, and allow the transmission of that over a conventional comms system back to whoever needs to make a decision. You still get the information at the rig site, but quite often it's the decision maker may be remote. We also were very keen on integrating both DAS and DTS into a single application, as well as all the other pieces of information that help create the complete picture of what's going on in the well. And that includes things like open hole logs, cement bond logs, completion and casing configurations, and geological data. So that whole range of information needed to be drawn in as quickly and easily as possible to create the image that we will then use to make an interpretation. The other thing that we're very conscious about is speed. We cannot wait for weeks before we get an answer. It has to be available in as near real time as possible, and we try and we certainly endeavour to get a quick look analysis out within hours of completing the survey. So the two applications that we have are Hot DAS and Quick View. Hot DAS is the application that's used to decimate the data and turn it into something that we can then ship around to the different decision makers. It's a two-stage process. The first stage is to run a Fourier transform, and it shrinks the data size down from terabytes down to gigabytes, and this file that it generates can be sent to whoever needs to see it. And then the second stage is the display, where the data is rendered into the images that we look at. The unique feature that we have is it's really simple to use. We can have it set up as a default settings, where the only thing the person needs to do is to browse to where the raw data is, browse to where they want the results to go, and then hit process and generate, and that's it. So somebody who is really not familiar or not comfortable with doing anything more than that, you can generate the files required very, very quickly and easily. If you wanted to be a bit more ambitious, then you could type in the frequency bands that you want, change some temporal and spatial settings on the data, and you use that to generate a more complex, richer set of images if you needed that. And what we end up with is for every single one of these tiles that you see in this slide, that represents the whole time period and the whole depth of the well. And we change to different frequency bands. So each column of data is one frequency band, and each row represents a different temporal or spatial setting. And it can make a big difference to the image that's generated and is viewed by the interpreter. So for instance, on this particular one, that's a 75 to 80 hertz 0-2 setting, and this one, it's 300 to 500 hertz 2-0 setting, and it makes quite a big difference. So what we end up with is a large number of images that can be used to cycle through and look at different features in the well. Certain things that occur in the well will happen at either different frequencies or different temporal and spatial settings. So one setting is not doesn't give you the full picture. The quick view application is where we draw all this information together, and so we're combining all of this information, the DAS, the DTS, any well logs that we've gathered, the geology casing, completion, etc., into a single coherent view of what's going on in the well. And it is very fast, very easy to use, and immediately draws the eye to a specific well problems, and just makes it so much more, the data so much more accessible, and B, it allows you to be quite flexible in how you combine those images and change some of the settings to draw out different features. Here, this is an example of a faulty gas lift valve, where we've got some temperature data on this track, which is a relative difference plot, where we take the first baseline and look at the change from that baseline as it occurs over time when we do something to the well. And the last track on the right here is a cumulative difference log. And so it just adds up all those differences and really draws out if there's any significant changes happening. And it's very, very clear that SIPOC command rule is leaking. And again, we can see that and pick that up in the acoustic data on the left-hand track. This feature that we see moving up the well at about 0.12 meters per second on the DAS, and I've maybe picked that in slightly the wrong place there, and on the DTS, that's an annulus liquid level change. So as we bleed off the annulus, that liquid level started off at this position and has moved up the well. So it makes it quite easy to pick up these types of feature. Another example where we were seeing through multiple strings of casing and right out into the casing to formation interface, and we're picking up some very significant events happening there that were unknown to the operator. On this occasion, we're picking up both on acoustic and on temperature. This one here is a little bit more subtle, but is quite a high spike. And so again, when it comes to things like pre-abandonment surveys, insight and information as to what's going on in the well will materially impact where you may choose to set plugs for isolation. And another one, this is an annulus leak where the cold fluids were injected, and we can immediately see the ported nipple at that depth was leaking, and we can see that cold fluids falling down the well, and again makes life very easy to pick up these types of fault. We can also see other features happening for deeper down in the well, and again we can see that in the acoustic data too. I want to move to a slightly different thing. So I'm going to come out of this presentation now and actually move to the actual application itself. So this is the quick view application. This looks quite a complicated image. However, if I wanted to start a new image, I've got all the information at my disposal here, so I can pull in my temperature data and make this is the absolute temperature, clone that track, and then just turn that into a relative difference, hit apply, and then we get quite a different view of that same data. And likewise, can change the scales to pull out a bit more detail in that. And again, clone that track again. And now I want a different view of this. Yeah. My mouse, once I get control of my mouse, I'll be in. So a successive difference plot gives us a slightly different view of the same data, right the way through to the final view. If I clone the track again, this time what I want to do is to go with a differential log. And that's how easy it is to build these sorts of views of the well. This feature here, if I wanted to know what speed that's moving at, click on the gradient. I want a new gradient. Mouse there, there you go. So it's moving up the way at 0.13 meters per second. So it's very quick and intuitive and easy to use. I'm going to create a little bit of space here, and we want to pull in the DAS data now. So here's my DAS data. Let's get rid of that fella, create more space. And now what I want to do is to, we generated a large number of images. Let's just zoom in on this. We generated a large number of images during the DAS processing, and this is image 1 of 198 potential images. So we can cycle through these and see how the image really changes. So there's a feature here that comes out loud and clear at that depth that is not there if we move one frequency band higher. And different features will come and go and strengthen and weaken as we cycle through these images. So the ability to very, very quickly cycle through these and look at where we're getting the best image generated and what the potential cause for that is actually a very powerful tool. But I like the idea of including a completion. So we do have the ability to include a completion schematic, and I can add the geology to that as well. So if I've got my formation tops, so I've put in my formation tops. Let me get rid of some of this. I just need space. I'm sorry, I'm doing this on a laptop, so my space is somewhat limited. And I'll just put the formations to the back. And it really does bring the whole well to life when I can see the geology, the casing and cement, any completion components that I'm dealing with. The survey only went down to Packer setting depth, which is why we don't have anything below that. And if I wanted to tie that in with conventional log type data, we've got logs that we can pull in as well. So if I wanted to pull in, let's see, yeah, a gamma ray log, a CCL log, let's put that on the same track. A CCL log, I can do so. Again, we've got all the usual zoom in, zoom out type features available to us. The other thing that's really useful, and actually it's surprising how little times we get this, is VDL data, so cement data. So again, get rid of that. So I can pull in cement log data if you have it, and if we zoom in, we can get right into the individual casing colors if necessary on a VDL trace. So that gives you a flavor of how quick and easy it is to render this information and generate that at the rig site if necessary. But certainly the the temperature data rather, those are relatively small files, and those can be sent via an email, and that brings in all of this type of analysis and view of the data immediately to the person that needs to make the decision. The acoustic data does demand a little bit of processing, and so there may be an hour or two to process the data and render the smaller file that can then be moved around the system. But then you're straight into generating these images as well. And so just to finish off my bit, because I don't want to steal all of Peter's time, quick view, simple, intuitive interface, giving the control to the user, whether that's the service company, the fella on the rig site who's under enough pressure as it is to keep a safe and efficient operation going, but also to the client, the end client, the operator. It integrates many different data elements and allows you to look at the whole range of data to make a final decision. And just to finish off with, we do offer support in terms of if you're buying equipment, what sort of equipment's appropriate for your circumstance, right the way through to learning a bit about optical skills, whether it's hands-on familiarization with the equipment, right the way through to the operation and interpretation type work. Again, those are all available. With that, I've probably taken up a fair chunk of time. I will hand over to Peter, who will run through the wire in a lot more detail.
Thank you,
Peter,
Mike.
over to you.
Yeah, thank you, Mike. Yes, so this is SlickLight DFOS logging technology. DFOS stands for distributed fiber optic sensing. And I will be actually giving a little bit more details or more light on the cable development point from cable development point of view. I'm not sure if everybody is familiar with the DFOS system, but basically it is what you see in the pictures on the screen. Actually, we are generating some pulses, electrical, then we turn that into the laser pulsing, and we launch that into the fiber. And what we do is collecting the backscatter from the fiber. We bring that to the detection, and then we turn that into the again to electrical signal, amplify that, and then when we have that as in the form of the numbers, we can process that. And actually, it's very, I would say, it's a kind of a it can be compared with the night driving and the snowflake reflection of light. Actually, it's great. It is using light, and it's a great method of measuring something or detecting something fully distributedly along the full depth of the valve. Our challenge was always cable. Actually, wires and bytes connects wires and cables with a quality data. This is our job. This is our focus. The SlickLight. It's actually new DFOS retrievable cable for the downhole application, and we started that as something which needs to be in the range of 3.2 to 4.8 millimeters. Of course, it started as a fully passive technology. Optical fiber, of course, is a passive element. But today we actually deliver that in combination with the copper. So even the fiber copper version of it is already in the market, and it's available. It brings actually the concept, the complete technology brings fast and real-time acquisition over the entire wellbore depth. Once the cable is in the well deployed, it doesn't need to move, because every single segment, every single meter is sensitive and will provide the data. So the cable does not need to move. The SlickLight concept actually involves simple pressure equipment and also smaller components on the well side. Like Mike already showed, there is not much equipment on the well side. Of course, Mike also presented the data scalability and more advantages of all these compactness, which is now provided, is decisions can be made on site or even remotely, because we decimate the data and you can upload the data, and then you can decide even remotely or combination site and remotely. All that within the few hours time. Of course, we want that always to be compatible with the traditional slickline tools like PT, gamma ray, CCL, and the rest. This is how it looks like today. All these three types. There will be more in the future. So there is a basic one which is it's just purely fiber optic. So in the center of the cable, you will only have the fibers. And the second one is already the hybrid one, in which we use combination optical fibers and also the copper, and of course electrical insulator to the outer steel jacket. And the third one is we call that heavy duty one, which has a stranding layer as well, providing higher strength of for that particular design. So it's all made, as mentioned before, compact and light. It's all made from corrosion-resistant wires, steel, high temperature proof, and of course we use geophysical grade fibers for these downhole applications. We already deployed that and the cables in Middle East, Argentina, UK, Saudi Arabia. Now it's going to be US as well, actually full package, which Tom mentioned before. From the application point of view, yes, it's DTS, it's DAS, but it's also with the copper we can also provide electrical signaling and also electrical power delivery to the tools. What SlickLight is and what it is not, it's very important to actually understand the difference between traditional wire SlickLight, which is actually full profile wire, and purpose of that is of course logging, but not only the logging, it's also different mechanical jobs, and it's of course can be also a part of the downhole electrical circuitry. Nevertheless, the SlickLight is a bit different than that. So it's based on tube-in-tube system, and this is mechanically a little bit different than full profile wire. So it's thick wall protective tubing in the outmost layer, which protects everything inside, fiber optics and copper wires. It's built for the logging jobs, yes, including DFOS, but also can deliver power and communication to the tools. And mechanical jobs, we need to be careful there because we have, of course, possibilities there, but of course we have also limitations. Like Mike already mentioned, you already saw what it can provide on the visualization side. DFOS, actually, the big advantage of it is it brings you special profiling, and it quickly pinpoints the spot of interest and for which you can bring more focus later on using your traditional SlickLight logging tools. Yes, some strength data. Of course, it's all in the data sheets, and everybody can see it actually there. It's of course it's produced in the lab facility for that. And one very important thing is about this cable, you need right handling. So, for example, you need to be careful on spooling. As I said, it's not full profile wire, it's based on tube. And therefore, you need to have right handling on already during the spooling, and some, of course, on the side. Well, there has been ideas in which you can combine things. So we've been asked even lately to provide, purely copper SlickLight. And the idea was to combine in one SlickLight unit the both technologies, copper SlickLight with the fiber optic one. So actually, the SlickLight unit can provide that. What is coming very soon, so it's already in the commissioning phase, is state-of-the-art thick wall tubing mill for the SlickLights. We expect the commissioning will end in November 2021. It will definitely bring cost efficiency in the manufacturing process because we will have one single layer as in the outmost jacket. It will bring some further benefits, which is easier sealing and more tensile strength. The wall thickness, the new wall thickness will go up to 1.24 millimeters, and OD can be down to 3.2 millimeters. Of course, this is a different kind of welding. It's not laser welding, it's special welding actually, and we will be doing all kind of super steel corrosion and H2S resistant materials. A little bit of the test facility there. So actually, not only for the downhole cable, all the cables are being tested in the temperature chambers, in the strain test benches, which is 80 millimeter long, small designs, bigger designs. It's all there to for full characterization of our cables. And we actually, for this downhole application, we developed even the, I would say, I call it simulation of a SlickLight sheaves, which is very important for the SlickLight operation. You need to know the size of your sheaves for particular designs, and this is what we actually provide as a service. We can always suggest best sheaves for different cables. You have to know these are retrievable designs, so they go in, they go out, and therefore we do these bending cycling tests with actually 2 times 180 degrees, and with the tensions, like you can see here actually. So the cable goes 2 times 180 degrees. We put the load up to 500 kilos. Well, the load cannot be seen in this picture, but it's behind this box. The load is applied. And sheaves which we test go all the way up to 1 meter. The sheave size will define your lifetime of your cable in this case. Well, with these machines, we also comply and we actually exceed IEC standards for the bend testing. In the facility, we do, of course, many different kind of cables, and we do with the customers and partners, we do DAS testing and product qualification. You will be amazed how much difference we can see in the different designs. For the purpose of the characterization, detailed characterization, so we have, of course, standard OTDRs, optical time domain reflectometers, but we have even specialized Brilliant equipment. I was involved in development of such a unit. So it's both BOTDA and BOTDR, and it's single-ended BOTDR and double loop, actually BOTDA. You need the both to characterize the cables. Yes, and we do all kind of electrical tests, customized testing, and completion of test documentation for the client. SlickLight strategy. Our strategy is use mature and existing equipment which is available in the market or you already use for your operations. We want to help actually provide the best we can different kind of quality data, whether it's DTS, DSS, or DSS data, and we want to help you on the efficiency side by just having operations getting smaller and cost effective, which is very important for the case hold business. And wires and bites, I think we are in our niche, we are a leader. We are very flexible in design, and all our production happens under one roof. And this is is proved to be a major advantage. A little bit on the facility, few photos from the facility side. So the largest is in Perm in Russia. It's where all these productions happens, and the second one is already for already a few years in Arlington, Texas, where they are more focused on OPGW and telecommunication business, but even this facility is growing very much. And from the wires and bytes side, that will be it. If you have any question, you can ask, and please do so. Thank you. Tom?
Thank you, Peter. So we can move now to the question and answer session.
I noticed that in the chat that there's somebody called Stuart Berry who's asked a question, can you power tractors through the copper hybrid fiber cable or only tool data? Peter, I'll let you answer that one.
Yes, this was already in discussion if we can power a tractor. Actually, yes, we can definitely assure the copper AWG15 is the best we can fit into the 4-point something slick line. It has never been done and needs to be tested, but the copper is there for the powering.
Masood is asking a question, what is the smallest cable OD for slick line?
It's 4.0 now, but in the future we will be heading to 3.2 millimeters thick wall.
Okay. Oh,
Michael is holding his hand up, so go ahead, Michael.
Michel LeBlanc.
I believe it's Michael, but anyway.
Oh. There's a question here from Octavian Titu. How do you address the stretch in the cable and how do you calibrate the temperature? So in terms of the calibration of the temperature, you've got a number of options. If there is a downhole gauge, permanent downhole gauge in the well, we can point to that and calibrate to that as a reference. Or what we tend to do is when we're running the fiber, we have a gamma CCL temperature and pressure at the bottom on memory. But if you've got copper, then obviously that would be surface readout, and we would use the temperature from the downhole gauge to help calibrate the fiber to absolute temperature. In terms of the stretch, I don't know if that's a mechanical question with respect to what wires and bytes do about stretch and cable, or if it's a stretch squeeze in terms of the data processing side.
Well, from the mechanical point of view, it's always our fibers are always longer than the physical cable, of course. But there are tricks we can play even with a careful design of the cable and using splendid techniques. We actually even tried the fancy material which are not steels, and that is for the future as well. So there are techniques how to protect the fiber against the stretch.
Okay, and then Octavian's also asking, have you considered a real-time viewer? And the real-time viewer, by that, I'm assuming something that as you're recording the data, you're rendering some sort of an image. You get that anyway through the DAS DTS units on the laptop that's controlling those. We do have the ability to pull in the DTS data as each profile is generated and append that to the image. But obviously with the DAS data, which is much bigger, we still have to go through the process of acquiring a certain amount of data to then do the frequency extraction. And that needs to be a certain length or time duration rather, because we apply different temporal and spatial filters to it to generate the range of images that we do. But I would probably run with a near real-time definition as opposed to a real-time viewer. So it's a little bit of semantics there, but yeah, it's not long. Stuart Berry's asking another question, which is, what is the general life of a SlickLight cable? Runs or bend cycles or distance traveled? And if your images had refreshed, Peter, we would have been able to see that really fancy rig that you've got for putting the wire through loads of different bend and stretch cycles. So maybe you want to say something about that.
Yes. So this is exactly why this test facility has been built, and we can. So all the SlickLight designs are planned for over 100 runs in the well. With some designs, we expect to exceed 1,000 runs. So it depends on the sheaves you have or you need, and it depends on the cable design. But it's at least 100 runs.
Yeah. Then Masood is asking, have you an example of production/injection profile evaluation using DAS DTS only? And the answer to that one is actually I don't on the stuff that we've done, but I do know that other companies have that data. It's just that we've tended to get involved with mostly the well integrity type things and sustained casing pressures and abandonment type things, rather than the cross reservoir type applications. But there's no reason why you couldn't use it for that. But the limitations then come down to the quality of the unit that you're using and its capabilities to get the resolution you need, specifically when the intervals that are either contributing to flow or accepting injection are quite close together. That starts to get a little bit more problematic. And this business about evaluating it, if I only have DAS DTS, I kind of like to think of DAS and DTS as being another tool in the box, and I don't actually want to give away other tools. I want to combine DAS DTS data with many other types of data, of which some traditional production logs are just one of them. And there's another question here: are fibers dipped in hydrogen scavenging gel, and is the fiber bend insensitive, and is it what's that say, as it bends, or is it compensated by, I can't see, that sounds like your sort of question, Peter.
Yes, of course, all the fibers are dipped in the scavenger gel. We use, of course, high temperature gels for these. There are few of them out there in the market, of course, and I mean, customer can even specify that. Is the fiber bend insensitive? Well, it is, but you have to know these. Everything is planned for the bigger diameter, bigger bending diameters. So even the sheaves in size are up to 1 meter actually. So in normal situation, you will not see the bending which will compromise the fiber. The cable will protect the fiber for these critical bending.
I think we've got to remember that if there's a need for bend insensitive fiber, then that fiber can be manufactured in the wire. It's not that we can't do it. It's just that you know, unless somebody asks for it, then there's why would you go to the expense of having something that is perhaps over-engineered for the application it's designed? So one of the things that we have is we've tended to use mostly single mode fibers, both for DAS and DTS, which gives us a bit of redundancy, but then the multi-mode is actually has been traditionally more useful for DTS, but is slightly more expensive, and so it really does hinge on what's the objectives of the wire and what's the service requirements for it, just in terms of making it cost effective but fit for purpose for the application it's being used for. Stuart Berry's asking another one. Do you have the slip ring and cable heads designed for hybrid copper fiber cable, and does this have a release tool? Certainly, there's no slip ring per se because it's static. We always run and deploy the fiber as deep as possible in the well, lock it in place, plug in the surface units, and then do whatever we want to do in the well with that wire static. And certainly the connection box designs are available for whatever configuration of wire you have, whether it's got fiber or copper. And so that's available. And then likewise, cable heads, there are cable head designs, again, manufactured for different purposes. So that is available. And then in terms of quick release, it is a releasable cable head that we have used in the past. So that is available, yeah. Any other questions? Somebody got their hand up. Somebody's got their hand up. Who's that? No, can't see it. Okay. Any other questions?
How many times can you circle cable? What is life expectancy?
Yes. So, well, that's the lab experience. I can tell you, it goes, you know, bending cycles goes far beyond 1,000 cycling with, I would say, different design, different sheaves, but bigger sheave, longer lifetime. Of course, but it's not only the sheave size. It's a design of the SlickLight and also the tensions which you plan to put on the cable. So these three parameters will define you the lifetime, and if you want maximum lifetime for your ideas and your application, we can suggest you, of course, which way to go.
And then final comment looks like from Octavian, who's saying that looking forward to jobs in Alberta, Canada. Canada's a nice place. I'd help with that.
And yes. We also have a short question. Can the cable be spliced if damaged?
Ooh.
What?
Can the cable be spliced?
If damaged.
Not now. it's a challenge. Not now, for the time being.
If there was a damage, you know, close to the wire, the tool head, then you would cut off the section of damage and then remake up the head to the remaining wire. If it's halfway along the wire, then no.
What is the maximum length for hybrids?
Yeah, 30,000 feet. Mm-hmm. Well, ladies and gentlemen, I'd like to thank you again for attending. Our marketing group will be emailing you a follow-up form to ask if you need to ask more questions and rate our presentation, and also sign up for the newsletter. I encourage you to contact myself by phone or email if you'd like to discuss the next steps in your pursuing this technology, or if you have any additional questions, and we can easily connect in the fiber experts like Mike and several others in his company. So that's no problem whatsoever. Mike's available 24/7. He's got sleep insomnia, so it's not a problem. Right? So, and you look on Wires and Bytes website, you can see my contact information. It's pretty easy. tom.oots@gmail and at wiresandbytes.com.
And Mike has just had a sense of humor failure.
Yeah. So thank you very much, and look forward to hearing from you guys.
Thank you.
Thank
Bye.
you.
Bye. Thank you.